graduated and I started my career in quantitative finance for more than 10 years. And then I used the knowledge that I built up throughout the years and put it into one of the pain points of wealth management. That is manual, very, very manual. And so this is the rationale of why we are doing what we are doing today. And the other thing is that on top of that, I'm also a mother of 3 and also a very, I call it an addictive runner. So in that way, automation becomes even more important in what we are doing. So in the next few minutes, I'm going to tell you a little bit more about what wealth tech is. In general, this is a big word, but what I specifically wanted to talk about is a small field. I'll tell you a little bit more later. And then I'm sure a lot of you know that people in the area of wealth tech love Excel. They have a passion for Excel. Whatever you do in Python, they want Excel. So how do we do the integration and how do we put it back into there? The third part is about monitoring and dashboard. That could help us to make our lives so much easier. And the fourth point is portfolio analysis and visualization. Once we have got some sort of a result, how do we visualize and understand and analyze we call it return contribution. Okay, so let's dig into wealth tech. Wealth tech in general is a very loose term. It just means that you put tech into wealth management. And then wealth management is a very, very big word. Some people would do trust kind of business or a very relationship-driven business. But what I'm going to talk about today is a very, very specific part, which is portfolio management. That is, how do you create a portfolio using different assets or different asset classes or different securities, whatever it is. Okay, so a bit of an elementary definition of 3 words: artificial intelligence, machine learning, and deep learning. A lot of people use these three words interchangeably, but here's a diagram to explain to you what the relationship are. So the biggest category is AI, and then machine learning is actually a subset of AI. And then we have deep learning, which is a subset of machine learning. Okay, sorry, more definition. So the next one is about artificial intelligence, or this is actually 3 important words in machine learning. If you take away one thing today and you don't know anything about AI, take away these 3 words so you can tell people that you know about AI. Supervised learning is the most commonly used way of supervised learning, machine learning method. It means that you're teaching it with the answer. What that means is a very typical example is forecasting the house price or property price. So what you have is the feature of the property. You know how many rooms there are, how many bathrooms there are, how many square feet, how far it is from the empty house station per se. And then you have the answer for that, which means that these kind of feature give you the output of what the property price is. And that means you have a correct answer for these set of problems. And then once you feed a new set of property, then you break down into the features. And then with that features, with the same relationship, the AI model will be able to forecast the property price of that. So this is supervised learning, very simple. And then unsupervised learning. Mainly we talk about is the clustering problem. For example, if you go on an e-commerce site, you'll be able to buy something, and then it will automatically recommend you to do something, to buy another product. So this is a very extendedly used example of where unsupervised clustering problem is used in. The third one is reinforcement learning, very, very powerful. One of the ways that I describe it is like how you learn to ride a bike. For example, you're learning how to balance on a bike, and you move your body towards the left, and it's a little bit too far, and your body will automatically adjust back onto the right side. So these kind of reinforcement learning of your brain, of the risk and reward that you give yourself with the action that you've taken, is called reinforcement learning. Okay, so let's go a little bit into the finance now. I need to give you a little bit of background of what portfolio management in order for me to explain to you a little bit better how we apply AI and other automation in there. So portfolio management really is about creating a portfolio with a universe of things, whether it's asset classes or different securities, a basket of things. And what you need to think about is, how do I optimize that basket of things? For example, if I have IBM stock, Apple stocks, how do I decide how much of these to buy when? This is the optimization problem. And then I'm going to introduce two terms. One is called expected return. The other is called standard deviation. So what we are doing here is to have the concept of creating a portfolio that has a minimal risk, but the maximum return. So first of all, expected return is how you expect the return of the assets, say IBM stock, say Apple stock, is later. So we don't have a superpower and we don't know what's happening next week. So usually what we use as the expected return is the historical return. Historical return meaning that what happened last week or last month, etc. And then standard deviation. Standard deviation is a statistical term. I'm sure you all know about it. And in finance, we call it volatility. That means how much the stock price has moved. And the higher the standard deviation or the volatility, that means it's more risky because it's more likely to go down to a very, very low price, for example. So all we are talking about portfolio management is to minimize standard deviation and to maximize expected return. So this is a more fancy way of putting it is you have an optimization problem and then you wanted to create a portfolio, a composition of the asset that you hold that sits on the line with the minimized risk and optimized return. However, what I'm going to tell you is we always use expected return using the historical return. And this is a very, very wrong assumption. That means you're assuming that what happened in the past is going to happen again in the future. And this is a very momentum-driven portfolio, and it's usually not the way that the real world works. And so we will need to ask the AI algorithm to help us to create us a better expected return using the forecastability that I just talked about. So apart from that, there are 4 examples here that tell you where you can apply AI in a portfolio management scenario. First of all, expected return. Using the AI forecast of the asset or asset class or the securities, and then adjust the historical return to make it to be a more realistic expected return. And then covariance is talking about the relationship between each of the assets. For example, the relationship of IBM and Apple, if one goes up, the other goes down. I'm just making it up. And you can use AI to do some forecasting and clustering to work out the relationship rather than having to use the historical relationship and expect it to continue for the rest of your life. The third one is optimization. So what I was talking about is also optimization. But with AI, you can put more complex constraint. And this really, really helped in a portfolio construction. And clustering is very typical. How you group different assets, different securities together, and it can help you to model the real world better. Okay, so we were talking about the house price relationship. That, for example, there are 3 rooms and the distance to the MTL. However, when COVID hits, the scenario changes. People value the size of the balcony, for example, more. And the distance to MTL station becomes less important. So this is one of the things that self-learning AI becomes very, very, very important. For example, you have a set of rules that you have built using the static group of data, but the relationship changed. And the AI needs to have the ability to evolve itself with the new adapted data and tune the model new parameters to make it into the realistic scenario that the world lives in today. So after the COVID, now we are resuming as per normal. So how does an AI model knows that the world changes? It all relies on the new data that comes in and the fitting of the model, hyperparameters, parameters. In that in order for the model to predict the latest case of the world. Okay, so let's take a pause here, and I wanted to talk about Excel here. So I told you about my previous experience working in a bank, and there are loads and loads and loads of people who are obsessed with Excel. They need to work on Excel, whether it's Excel formula or display in Excel. And us, as a Python native person, it becomes very hard to convert your codes into Excel. So one of the very, 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 very simple techniques is to integrate the two things. And for the next few minutes, I'm going to show you the tricks, and my codes are also on the GitHub. It helped me, and I reuse it for, I think, 100 times at least. So first of all, you can take the Excel parameters from the Excel sheet, which the user can fit in. And then you can fit it into the Python code using a parameter format. And you run your Python code, and you return the result as an CSV or whatever that sits in the file system. And the last part, you ask the user to import back the result back into the Excel that they love. So here's a quick example, and you can have a drop-down list, whatever it is, and then choose whatever it is, and then feed that as an argument. You can see that there's a name list, file list, which is taking the name from the sheet. And then you need two things, the Python executable and the Python script, and you just run it using a very simple string. And then you will kick off a shell window, and the shell window will be able to run the Python code behind the scene. And then in the Python script, I used rpos, so you can take the parameters, which for here it's -n, which is the name, and -f, which is the file, and feed it into the codes. And then finally, I use a very simple Python. So you can see in the function, the name list and file list are fed into here. And then finally, I used pandas to CSV function and save it into a.csv in the file system. And then I have created a file. So whether it's a Unix or whatever file system, it will all work. And then this is a very simple import function. What it does is open up the CSV that we just created, and then with the it copies the data back into the master workbook. Simple as that. So this is exactly the same sheet. Apologies for very simple and basic things I just put together for the purpose of today. So something like that, and this automatically changes. I wanted to talk about this function too. It can allow you to do all sorts of fancy things when you allow one cell changes and the other cell changes using a function. It's also in the codes that I put on GitHub. So you can just run it. And then you can import the result back here. So here it is, very simple, and it is the most useful thing I found working in a bank. Okay, so let's continue with this one. I think it's this one. Okay, so the next one I wanted to talk about is monitoring and dashboard. Why do we need that? All our end-to-end system is automatic, which means that I can stand here, I don't need to look into the system, and we've put our system behind many, many firewalls for security reasons, so which makes it very difficult for me to go in the system to look at the status and what's happening. And also what is more important is I need to know if there is any issue, any problem, what's displayed out from the system. So here is, again, a very simple set of tools that will allow you to do that and free yourself from constantly monitoring your system. In this dashboard, we use Grafana here. And there are two main purposes of that. One is the status of processes, and the other is business information. Status of processes, what I mean is we have got lots and lots and lots of process. we need to understand at any point in time, for example now, how many of the process has running, successfully run, fail, or there is an issue that I need to address. So by having a one bird eye view, you'll be able to see all the process status as of now, what is happening now. And the next one is business info. What it means is rating of each asset classes. So you can see that there is a distribution over time. And what is quite important in this screen is it gives you an intuition of visualizing what the output is. And it allows you to spot any anomalies if there is any. So by looking at the database, it is quite hard for you to spot anything that goes wrong. But if you have a time series of data like that, you can immediately see there are big changes over here, and then you'll be able to dig into that part and see what's happening over there. So Grafana is very easy to use. It is just using a SQL query to query into the database that I mentioned earlier that you write the result into. And you can display all sorts of things using the UI configuration only. And this is the database actually storing the actual percentage of each asset class. I've hidden the symbols. So on any any time, you can query into that and then create whatever query you want to display what you want to see. Okay, so moving on is the last part about portfolio analysis and visualization. Why do we need to know about visualization? A lot of people, asset managers, traditional investment manager, because we are talking about a very traditional industry, that is wealth management. People are very, very traditional, and they wanted to have some explanation and understanding of why we have created the portfolio it is. And it's also very important to explain the return that we have created in the past. And so I've got some graphs, and I hope I can give you some ideas of ways of presenting the portfolio composition. So this is a typical graph about cumulative return of different portfolio stocks or asset class or securities, and this is the portfolio output. Doesn't make any sense, right? You cannot possibly understand what's behind the scene. By stacking them up, it becomes so much easier to understand the return contribution. So I've hidden the names here, but the concept is you know that over time, what has created the positive result for your portfolio. And for example, in 2020 March, when everything dropped, what has dropped and what has not, and where is the contribution coming? And the negative part is consistently not performing over the years, and I'm sure you can guess what it is. This is another good way of presenting, is we are talking about allocating portfolio. For example, I need to tell people my allocation, whether I put 20% of Apple is a strategic and good decision. So what I can do here is to put two lines together. First of all, is say this is Apple. This is the price of Apple itself, and this is by doing my asset allocation, what I have done to Apple in order to outperform or make it worse in different time scale. And then I will show the composition in the dotted line too. So these codes are also up in the Git repository, and it's quite simple. So if you have any question, feel free to get in touch, and I can show you a little bit more about the stuff there. So that's pretty much all I have for today, and feel free to ask me any question. I tend to make it a little bit shorter so we can have more time to discuss.
You may raise your hand if you got a question.
Thanks for the talk. I just wanted to know, is this still in the development stages, or are you like already managing assets currently?
So our company has started our R&D around 5 or 6 years ago today, and we got SFC license in 2021 October, September time. So we have been managing asset for a little bit over a year now, and that we have got different sorts of portfolio, including the all-weather portfolio and different partnership of creating, say, an ESG portfolio, a crypto portfolio, using the tools that we have built together. So mainly we are supplying our AI engine and the AI models, plug-and-play modules, to do dynamic asset allocation, asset class prediction, and crash protection. What that means is we are predicting if the market has got severe volatility coming up. If there is a high probability of that, we'll take the portfolio cash out so that we will be less affected by market. For example, now we have a very small exposure in the market because of those kind of signals to make it more conservative and make it easier for us to reduce the volatility.
So this is more of like a risk tool to monitor market volatility, and like I assume, that being said, like this is more geared towards like mid-frequency to low-frequency trading.
So first question is, we are doing sort of a discretionary managed portfolio. What that means is our client will open an account with a broker, and then it will be tied into us. And so it's discretionary managed account into their broker account. So it's all automated, and they don't need to do anything, but they will see the balance balance moving on a daily basis. And the second question is the frequency. So yes, it's a medium long-term portfolio. The trading frequency is up to every day, but of course we have to balance between the commission and the advantage of doing that specific action. So typically I would say is about two trades per week, something like that.
Okay, is anybody got another question?
Hi, thanks for the talk. Would you mind talk a little bit about the database? I'm interested in what are the source of truth. I mean, the dashboard are derived from some data source somewhere else. The Excel and the Python script are derived from something else as well. So are you using some kind of time series database or traditional relational MySQL, something like that?
It's traditional structured database. And so let's put it in two parts. So first of all, the monitoring part, which I was trying to demonstrate just now. It's all a rational structured database that we print the result into the database as a time series. And that time series is specifically corresponding to the status of the process. What it means is, for example, I'm getting the data from one source, and then I am cleaning it, and then I'm calculating the adjustment. And for each of the process, I'll have a status for it. For example, stage A done, stage B done, stage 3 done, for example. So this is about the monitoring part. And the other that you mentioned about, I assume is on the machine learning part of the database. So it's again more sorts of the structured database that we use. We've got unstructured data too, but we will process the unstructured data and make it into a structured format of data and then store it into the database. So this is our current infrastructure, and I'm sure you sort of understand that unstructured data can be quite noisy. And so we put a lot of focus in getting the unstructured data cleaned and making the structured data before we put it into our models to be trained.
Hi, thank you for the talk. I want to ask about the final part of your presentation about the return or maybe the contribution and attribution analysis part. Can you talk a little bit more about that? And maybe, I guess the question is, what type of contribution analysis do you find the most useful or the most interesting? And can you give an example of it?
Okay, so maybe I'll talk from top-down level. So what people are interested is Sharpe ratio, drawdown, return. So these three things go hand in hand. First of all, one of the portfolio analysis that we do is to find a very fair score that accounts for all these three elements and present it in a way that we are not only optimizing the total return or the Sharpe ratio, but a mixture of all these things. So this is one of the things that we do. So breaking the three things down will be the return contribution, which I sort of give you some ideas about stacking up and then understanding on a portfolio level what has contributed so much about that. And what is, again, more useful is comparing different setup of portfolio and your benchmark using that kind of stack graph. And then you'll be able to do, do all sorts of fancy things like the delta between the two things, or delta specifically for 1 year, 2 year of the crisis period, and how do you define the crisis period. And then the third one is the drawdown. Drawdown graph is, again, very, very important. What is more important is comparing different portfolio and benchmarks drawdown too. You can explain to people your total return has added that much because you have avoided the downturn or avoided a big drawdown at this period of time. So this is, again, a very qualitative problem, and you have to understand different scenarios, like on a bull market, on a bear market, on a flat market, how your portfolio do compared to the benchmark or all the other funds, hedge funds, and where are your advantages and how do you display it? Is it in terms of drawdown? Is it because you have avoided a big drop in order for you to gain the return that you have, or you have consistently beat the market on a bull market, etc.?
So thank you for your presentation. I would like to ask a little bit of first question is, have other database been considered to be speed up, or is it just merely a limitation on resources or maybe nuance? It is for low frequency trading. It is just merely that you can give the results faster to your customer to let them review, or
I guess the sort of way to improve isn't on the database, but the computing power. The database is a small part because I mentioned that it's not written as frequent as some people would like high frequency trading. So the amount of optimization of energy, resources, speed is not that much. But if you're talking about computing power, then there is a lot of room. Computing power, how do you scale up and down depending how much usage you have? I'm sure you know machine learning models has got needed quite a bit of CPU, GPU, that kind of resources. And so we have spent some time in our scalability too. What we are using is not cloud. We are hosting our own bare metal platform. In this way, we'll be able to more precisely scale up and down and make it parallel scalability that is possible. So this is, again, with trial and error over the few years, and we find this the most efficient for us. It might not work for other people, but it is the best as of now that we have. So the third question was, the second question was explainability. Very, very relevant question, because this is the most important thing to an asset manager. How do you explain the result? So there are typical ways of doing this. First of all, very data scientist way is understanding accuracy, recall, precision, that kind of metrics, and then you'll be able to understand a little bit more what's behind that. And the second one is to break down, we talk about explainable AI a lot in the industry, that we cannot allow it to be a black box. So what we do is we chop the black box into as small processes as we can, so that with each process we understand the input and output, and we can form a better picture. Not that it's completely transparent, but at least we know a lot more data points on what it is. And then you'll be able to, for example, in neural networks, you'll be able to understand or compare the nodes, activation nodes, that kind of things. That gives you some intuition. Another very useful techniques is the minimal change required to produce a different outcome. For example, it's predicting predicting something to be higher in price next week, and so you will change your input parameters to a point that it has given you a completely different decision. In that way, you have some sort of intuition too. The last thing is creating dashboard. So by printing out what I call the input and output of each processes, and then display it to, for example, myself or the other data scientists, you will again form a better picture of how these parts linked up together.
No, because I guess when it comes to interpretability, because for clarification, when it comes to interpretability, I'm not necessarily just referring to just like an input-output check. It's more in a sense of internal logic check, because for example, when it comes to like random forests or other, non-direct aggregators, very often people will create like a kind of presentation like, because of conditions X, Y, and Z, I make decisions A, B, and C. And there's basically like a line drawn between like a cause and effect thing. And for a lot of models in the public, you can't just draw a direct line. When it comes to like time series, however, it's even like more difficult to make a direct like human-esque judgment to present to your clients, right?
Yeah, I guess there is no perfect answer to this question, and this is also one of the core fundamental concepts that we have in machine learning too. So to make it a little bit more transparent, what I would say is to combine the traditional domain knowledge into the data scientist expert knowledge. What it means is for the domain expert, they will have some sort of a gut feeling to understand the feature importance of what comes out. And then they will be able to rationalize whether that is really the key of something that is happening now in the market to correlate back into the decision of the model.
All right, due to the time limitation, I guess we can have one more question to Rebecca. Anybody got an extra question?
Hi, I was wondering about your thoughts on sentiment analysis, on using that kind of data to base investment in stocks, yeah.
Okay, so I assume you're talking about unstructured data and then using NLP to turn it into sentiment, that kind of workflow, right? So different asset class and different specific stock, the usefulness is different. For example, if you're talking about fundamental data, which is the financial statement, balance sheet, etc., it only comes once every quarter. So every time it will be already priced in by the time that you analyze that and get the result back. So if you're talking about news and unstructured data, social media, it will vary depending on what asset class you're trying to predict and whether it will be creating some noise, that kind of thing. Then you have to experiment on different methods. And so my short answer is it will be useful on some asset classes, but the noise to signal ratio can be quite high too.
Okay, thank you, Rebecca. I think we can have more discussion after this session. And thank you again for Rebecca. And then our next session here will be started at 11:45. Thank you, Rebecca.
Thank you very much.